Hi, most of time whenever you conduct a stress analysis in ANSYS or in the software, you might realize you are not sure whether the results you obtained are accurate. Therefore, in this video, I'm going to try to answer the following three questions. One are my results accurate? Are they accurate enough? And is there a rule one uses to decide the accuracy of results? Therefore, our video today will focus on adaptive convergence. I have this bracket that is made of structural steel for the material. Mesh, I'm using default mesh that is not refined. This video will enable us to help us how to define or how to refine mesh. Fixed support, I'm using this back face, and now I'm applying the pressure on this face along Z axis and a force on this face along Y axis. As you can see, my model is approximately, as you can see from this scale here. Let me pan. This is how you approximate the model length, approximately 800 mm from this bottom scale. Okay, therefore let's run this. Let's insert strain, the deformation total, and run. As you can see, we obtained 0.88 mm as our total deformation. Are you sure this is the accurate results? As you know that the finer the mesh, the accurate is the result. I'm going to illustrate what we call adaptive convergence. The adaptive convergence for the finite element analysis means system response, for example, the deformation or stress, converges to a repeatable solution with decreasing element size of a well-defined model. Therefore, the more you refine your mesh, the value of maybe total deformation tends to be constant. That is what we call adaptive convergence, whereby this value doesn't change or the changes very little. Okay, we are saying the results no longer change with mesh refinement. Okay, therefore we need now to refine this mesh, but not manually. We're going to use the software to do that for us. Therefore, as you can see, this is the mesh, how it is. You just right click on the total deformation, you insert convergence. As you can see, this is the total value, this is the maximum value, the total deformation, the highest value of our model that is happening at this node. If you go back, this value corresponds to this value, 88502, 88502. Now, how can you know now? How can you control the convergence of the total deformation? We use the convergence details here. Definition, we are using maximum. You can still use minimum if you want, and which is 0. If you go back, you can see the minimum is 0, minimum. If you probe here, if you probe at this point, if you probe, we get 0. You always get 0 at the fixed support. Therefore, we don't need minimum, we need maximum. When we want to determine the final results, we use allowable change. We usually use what we call relative accuracy. This means the solver takes the value at specific mesh of the total deformation, refines the mesh, and calculates another total deformation. If the total deformation is within 20%, 20 or below the change, then the solution has converged. But if after refining the mesh we realize that the change is not within 20%, the solver refines again depending on the depth. I'll go back here. Therefore, I want to use 5%. This means the difference between the refined the new solution of the total deformation and the previous solution should be within 5%. Then I go back to solution. Let's go to the adaptive mesh refinement. The first one, that is the depth refinement. Depth means elements formed per previous mesh. If I use 3, this, for example, if I use this element here, let me use this element, you can't pick, just as you go element, in the adaptive mesh refinement, 3 means it will form 3 elements of that specific element. Okay, therefore for the aggressive refinement it uses a big number, hence we get a final mesh. If I use 10, for example, refinement depth 10, it will scale down that specific element with a scale factor of 10. Let me use 3 for now. Loop, I'm going to use a loop of 1. This means for each iteration it refines the mesh as per refinement loops. 1 means with 1 iteration solver will try to refine the mesh 1 time and report the results. It just goes 1 loop, then publishes the results, goes to the next depth, goes 1 loop, publishes the results. Okay, therefore let's now run the solution. Always note that it takes some time because of the refinement of the mesh. Now our solution has already converged. You can see now my new total deformation is this value 0.88597. That is more accurate than this. If you go back to, I'll have our new value. Now let's see what happens to the mesh. Let me open let me display elements. You can see now the elements has been refined non-uniformly because the software selects the appropriate surfaces to refine the mesh. That's how we use the adaptive convergence. Thank you.